Hello everyone and welcome to my channel. Today I'm going to teach you how to solve rational inequality. Rational inequality is an inequality which contains a rational expression, where a rational expression is a ratio of two polynomials. So let us jump straight into this example. X minus 2 all over x squared minus 3x minus 10. So all of this is less than or equal to 0. So as you can see, it involves rational expression. And the inequality symbol is less than or equal to. To solve this, let us follow the following steps. Alright, so let's do it. Step number 1. Write the inequality in general form. Meaning, rewrite inequality as a single fraction on one side and 0 on the other side of the inequality. So, as you can see, the left side of the inequality is already a single fraction. So by the way, single fraction is of this form, a over b. So where a and b are polynomials. So on the other side is already 0. So hence, we are now ready to proceed to the next step. Step number 2. Find the zeros of the numerator and the denominator. The zeros are the x value or values that make the rational expression 0 or undefined. So if you find it difficult to find what value or values the numerator and the denominator are 0, then factoring may help you. So now, let us factor the numerator and the denominator completely, or get all the prime factors of the numerator and the denominator. So since the numerator is already a prime polynomial, so let us now set the numerator x minus 2 to 0 and solve for x. So the value of x here is positive 2. So because if we're going to transpose minus 2 on the other side of the equation, so we have 0 plus 2 and 0 plus 2 is positive 2. So the value of x here is positive 2, and this is the value that will make the numerator 0. The denominator, on the other hand, is a quadratic trinomial. In my previous video, I give you already the steps on how to factor this kind of expression. So, x squared minus 3x minus 10 is x minus 5 times x plus 2, because the factor pairs of negative 10 that gave us the sum equal to negative 3 is negative 5 and positive 2. Now, to find the zeros, let us equate each factor to 0. So x minus 5 is equal to 0. So solving for x, so we have x is equal to, so transpose negative 5. So we have 0 plus 5. So 0 plus 5 is positive 5. So on the other hand, so we have x plus 2 is equal to 0. So x here is, so transpose positive 2. So we have 0 minus 2. So 0 minus 2 is negative 2. So x here is negative 2. Step number 3. Mark each of the values in step 2 on a real number line. So using shaded or hollow circle. It is shaded if it is included in the solution, and hollow if it is not included in the solution. Take note that zeros of the denominator make the rational expression undefined. So, they must be immediately excluded or disregarded as possible solution. Hence, positive 5 and negative 2 are not included in the solution. And let us mark these values using a hollow circle on the number line. Alright. On the other hand, positive 2 is the value that will make the numerator 0. So what will happen when the numerator is 0? So the rational expression becomes 0. So when the rational expression turns to 0, so after substituting x is equal to positive 2, then one of the resulting statement is true. So 0 is not less than 0, but 0 is equal to 0. So since one of the statement is true, then that makes the whole statement true. So 0 is equal to 0. So therefore, x is equal to positive 2 is included in the solution. So hence, let us mark this value on the number line using a shaded circle. Let us proceed now to step number 4. Use the values in step 3 to partition the number line into intervals. So for illustration purposes, let us draw vertical lines passing negative 2, positive 2, and positive 5 respectively, to show partitions. Now, let us write their corresponding intervals. Negative 2 to the left. So when you say to the left is to negative infinity. So we write an open interval, negative infinity to negative 2. So take note that in writing interval, we just write the beginning and the ending numbers of the interval. So the beginning is the lower bound and the ending is the upper bound. So we use bracket when we want to include the end value, or parentheses when we don't. Further, parenthesis is always used for positive and negative infinity because it can never be an endpoint in an interval. Okay, how to write the next interval? So the next interval is a left open and right close interval. So negative 2 to positive 2. So the beginning, negative 2, uses parentheses, meaning that number is not included in the solution, and positive 2 uses bracket because it is included or marked using a shaded circle on the number line. So how about the next interval? So the next interval is left close, right open interval. So positive 2 to positive 5. Positive 2 uses bracket, so meaning it is included in the solution or part of the solution. And positive 5 uses parentheses, meaning it is not included or part of the solution. And the last interval is a left bounded and right unbounded interval 5 to positive infinity. You can also write interval notations to inequality. So, any value to the left of negative 2, say x, is less than negative 2. So, we have x is less than negative 2. Also, any value between negative 2 and positive 2, say x, is greater than negative 2 but less than or equal to positive 2. So we have x greater than negative 2 and less than or equal to positive 2. The next inequality is x greater than or equal to positive 2 and less than 5 because any value x within this interval is greater than or equal to 2 and less than 5. So lastly, the inequality notation for the interval 5 to positive infinity is x greater than 5 because any value x to the right of 5 is greater than 5. So, these are the corresponding inequality notation based from the given intervals. Step 5. Choose a test point in each interval and check if it satisfies the original inequality. Test point is any sample value within the given interval except for the zeros of the numerator and the denominator because we know already if those values are included or part or not part of the solution. So pick or choose any value within the interval except for the zeros of the numerator and the denominator. So we have negative 3 for the open interval, negative infinity to negative 2, 0 for the interval, negative 2 to positive 2, 3 for the interval, positive 2 to 5, and 6 for the interval, positive 5 to positive infinity. So now let us test each value if it satisfies the original inequality. I suggest create a table like this to make it easier for you to identify which interval is the solution to the given rational inequality. Take note that if the test point satisfy the inequality, then all the values within the interval also satisfy the inequality. Okay, let's do it. Substituting x is equal to negative 3 to the inequality will give us negative 5 over 8 less than or equal to 0. Is this a true statement? Yes. Negative 5 over 8 is less than 0. Take note that if one operand or statement is true, so negative 5, 8 is less than 0, even if the other operands or statement negative 5, 8 is equal to 0 is false, then the compound statement is true. So that is by the rule of inference logical disjunction. So hence, all the values within this interval are the solution of the given rational inequality. Substituting x is equal to 0 will give us 1/5 less than or equal to 0. So this is false statement. So therefore, all the values within the interval, so negative 2 to positive 2, are not included in the solution. Now, substituting positive 3 to the original inequality will give us negative 1 over 10 less than or equal to 0. and one of the statement or disjuncts is true, so negative 1 over 10 or negative 1/10 is less than 0. Hence, the compound statement is true. Therefore, all the values within this interval are the solution of the given rational inequality. Lastly, substituting x is equal to 6 will give us 1/2 less than or equal to 0. And this is a false statement. So as a result, all the values within this interval are not included in the solution. Step number 6. Write your answer as an interval or inequality notation. So there are two intervals that satisfy the given rational inequality. So we have the open interval, negative infinity to negative 2, and the left close right open interval, positive 2 to 5. So to combine these two sets of values, so we have the union of the open interval negative infinity to negative 2 and left close and right open interval positive 2 to 5. So what does it mean? So meaning to say all the elements belonging to either or both intervals satisfy the given rational inequality. Another way of writing the answer or the solution is using inequality notation. So, we have, so x is our solution. So, x is an element of real number such that x is less than negative 2 or x is greater than or equal to positive 2 and less than 5. So this is the solution of the given rational inequality.